Hello, my name is Shivam Ingde and I am data science intern from oasis infobyte, and this is my task 2, and today I am here to present you my project which is on iris flower classification. So let's start our project. So this is my GitHub link, and we have the problem statement. Iris flower has three species: Sentosa, versicolor and virginica, which differs according to their measurements. Now, assume that you have the measurements of the iris flowers according to their species, and here your task is to train a machine learning model that can learn from the measurements of the iris species and classify them. So what we have to do in summary, we have the input of sample length, supplement petal length and petal width, and we have to make an output of class of the flower. So at the first we will import the libraries in this project. We have used NumPy, Pandas and Seaborn and Matplotlib. Now after that we will load this data set. So this is our data set. We have sample length centimeter, separate length, sepal width centimeter, petal and centimeter, and petal width centimeter and species. Now we will rename the complex column now because we have a complete some complex name like this. So we will just make them simple. So we will change the sample length centimeter to sepal underscore length, sepal bit centimeter into sample underscore width. Now we will print the head by which we can see the top 5 rows of our data set. Now as we can see, compare these names are quite easier and comfortable for us. After that we will check the null values. So here we have zero number of null values in our data set. Now we will check if data is based or not. So here we have Sentosa, versicolor and virginica are 50-50 each. So the data is not based. Now we will check the statistical feature by dot describe method. Here we are able to see the count, mean, standard deviation, minimum, maximum, 25, 50 and 75 percentile of our data set. Now we will do visualization. At first we will plot a scatter plot, and here the blue is for Sentosa, orange is for versicolor and green is for virginica. Here we can see the Sentosa is quite easier to classify, and this versicolor and virginica are some of the mixed data set. Now we will do a pair plot. Here we can see the data sample length, and here we have the blue color is Sentosa, orange is versicolor and green is for virginica. Here we can clearly see that which species has the highest longest sepal length. So this is the blue color, means Sentosa has has the longest upper length, and here we can see the longest sepal width is of the green color, which is the virginica, and longest petal line is for blue Sentosa, and longest petal width is of again blue Sentosa give. And here we can see the petal width to petal length. So this means if it is 0.5 more than little bit more than 0.5 and up to 2, the flower is Sentosa, and so on. Now we will separate in input and output columns. So here we separate features and targets. Now after that we will slice the matrices. So this is our X. We have 150 rows and 4 columns. These are the rows and columns, and Y we have 150 rows. After that, splitting data into training and testing. So here uh, we have used the train test plate. We created X train and X state and Y train and Y test. And in our X train we have 1 to T rows with 4 column. Our size is 0.2, which means 20% of our dataset will be used in testing and rest of the dataset is used for training. After that, as you can see here, we have Y test. We have 30 rows for X tests and we have 30 rows and 4 columns, and for Y train we have 120 rows. Now building a model. So our first model is support vector machine algorithm. So here we have import svc. After that we made a prediction model, we calculate the accuracy, and here we can see we have 96% of accuracy. After that, second model is a logistic regression. At first we will convert categorical variables into numbers. So we will map our data set like Sentosa is for 0, it is a verticular is for 1, and Virginica and is for 2. So here you can see the spaces is 0. Now we will prepare input and output. So here we have imported the logistic regression, and our accuracy for the model is 97%. So we will make prediction of our 150 species, and this is our prediction. After that we summarize the fit of the model. So here we can see 0 is for Sentosa. So for 0 the prediction is 1 recall, and F1 score R1, which is means 100%, and for vertical precision is 90% recall in 94, and F1 score is 96%, and for Virginica we have 94% of precision, recall is 98, and F1 score is 96%. And after that we will make a confusion matrix, and here we can see Sentosa. It predicted Sentosa all 50 columns, and here it predicted 47 of for vertical and 3 for Virginica, so it is 96%. And after that it predicted 949 and 49 values for Virginica, and one for vertical, which is up to 98 or 96%. Right now our third model is Now our third model is decision reclassifier. We imported this entry classifier, we predicted, and we got 96% of accuracy. Now we will upload a new data for prediction. This is our new data, and we predict, and we got 0, 1 and 2, which is means this is 1 is for Sentosa. This one is our versicolor, and this one is for Virginica. Thank you.